It's Thursday, June 27th. We have, this is the last day of the third quarter moon. We're going into the fourth. This is high astro season. The plan for this evening, well, I'll leave that open and explain that later. Of course, obviously, it's a bit too soon to be doing any astro. The sun is still up. It's behind the house over there. I'm going to open up the observatory, mount the camera, set the time. I have to subtract. It's been I wasn't able to observe last night because of the cloudification. So I'm going to have to delay the clock by about 6 seconds on the Gemini 2. What you're seeing me do now, of course, is opening the observatory for the evening's activities. It's a bit windy. I don't want this blowing open, nor do I want the door slamming on me, so I take these precautions. Next step is turn on the Gemini 2, let it boot up as I open the south-facing on this copied-looking prototype of an observatory that anybody could make if they went back and reviewed videos done earlier in this astro sequence on Golden Phoenix Publish. Balance is not too bad. Bubble is a little left of 0. Maybe that'll be fixed. I may actually end up doing a mechanical alignment. I don't like the values in the model parameters. Okay, once the handset comes up, you press warm restart. And then you go to menu, time, count 1001, 1002, 1003, 1004, 1005, 1006, hit set. Now I should be pretty much synchronized. I should be able to turn the scope on Vega right now. And you know what? I think I will do that. We should actually be able to make it out. So press the Go To button, go to Bright Star, look down the list for Vega. However, it may be a bit too far to the east. We'll see. It says it's minus 4 hours from culmination. Let's spin it around on it anyway. I do need a nice bright star in order to be able to see it while the sun's still up. I don't give it high probabilities that we'll make it out. As you can see, the Gemini 2 Losman mount in action, folks. There it is. It does all the hard work that I used to have to do for myself when I had an EQ3 and pushed the scope around. Manual, Go To. Tonight we shall try something interesting. And the thing we're going to try is I'm going to start out right now with the last of the springtime studies. It's basically culminating. The time is 9:38. This particular study, with the sky still quite bright, is a globular cluster. I'll give you data on it, and I won't tell you until the end of this each and every video sequence and study I'm going to show you this evening what it is, but I will give you the data. But I will add it as a caption at the very end of each roughly 1 minute long section. And I'm only showing you this one because I want to transition later on this evening into summer studies. Every one of these deep sky studies will, however, be recognizable to anyone who has done a Messier Marathon in the past, because they will all be Messier deep sky studies. Let me give you the data on this one, having introduced the concept for the evening. So don't feel bad if you can't recognize a single one of these. That's perfectly fine. I probably wouldn't be able to either. But I just thought it might be very interesting to capture each of these studies in this way. Although the screen is quite bright because the sky is well before sky dark, you can obviously tell this is a globular cluster. Now, I'll give you some data on it. This is a globular cluster in Serpens. Quite bright, magnitude 5.7, fairly large, 19.9 arc minutes in size. It is 24,500 light years distant. Its right ascension is 15 hours, 18 minutes, and 33 seconds. Its declination is 2 degrees, 4 minutes, and 58 seconds above the celestial equator. So, having provided the information and having introed the concept of the evening, we shall bid adieu to this particular globular cluster, and we will await another half an hour to 45 minutes for sky dark before we will explore various Messier studies beginning right at summer and then progressing ways through it this evening. All right, we'll get back to this later in the evening. All right, with Leo dipping down to the west and Ursa Minoris, the little dipper, high overhead but invisible due to the fact that it's too far north for the observatory, we are having another look at globular cluster Messier number Serpens. The scope has now had to do an equatorial flip, and as I mentioned earlier, this particular globular cluster is the last of the late spring studies in the Messier catalog. And we are about to begin a tour of studies in the summer catalog. And there's a view at the normal viewing angle of the past. Here I am zooming in, and we will go ahead and use the zoomed in position tonight because these, hey sweetie, these are all Messier studies, nice and bright. They should give good views even when the screen is full size. So bidding adieu to Messier number 5, we will proceed to a roughly culminating study to the south. Okay, here we have our next Messier study, also once again, obviously, a globular cluster. This one's quite distinctive among globular clusters. In fact, it is the basis for my a project I originated last year where I used this as the holotype for globular clusters in order to determine their size and distance and luminosities. This one happens to be in Scorpio. It's magnitude 5.4, quite large, larger than the last, 26.3 arc minutes, but a mere 7,200 light years distant. And if this one was pushed off to the distance of the last one, it would be roughly 4 into 26 goes 5 times, only 5 arc minutes in size at that same distance. And the last globular was 19. As mentioned, we're in Scorpius. We're at right ascension 16 hours, 23 minutes and 35 seconds, and a deep south declination of minus 26 degrees, 31 minutes and 31 seconds. And that is our view. Go ahead, take a shot at it. Which Messier do you think this is? Easily enough, it's numeric. All you got to do is figure out the right number. The last study I wanted to show you was a Messier as well, but it was an open cluster, Unfortunately, it was too far south and to the east. It's behind the trees. We'll have to revisit it later. Here we have a third globular cluster, this one in Ophiuchus, magnitude 7.9, smallish 5.5 arc minutes in size, 25,800 light years distant. Given that 5.5, it's about a third the size of the very first cluster we had a look at. This one's at right ascension 17 hours, 19 minutes, 11 seconds, declination minus 1830 and 59. I've noticed in the Messier catalog on the Gemini 2 data set, they do not specify what class of a cluster or galaxy or anything else. They just give you raw data about apparent size and magnitude and distance. This one looks reasonably condensed. It's probably a class 5 or 6, but I'm only speculating by looking at the image. 5.5 arc minutes, by the way, should be about a third the size of this screen. So this cluster actually would cover about that much of the field. What you're seeing here is closer to 2.5 to 3 arc minutes in size. So that is our third cluster of the evening, only 2 of which are summer sky studies because the first was actually a late spring globular cluster in the Messier catalog. And of course, we now have another summer globular cluster. This one is in Ophiuchus. It's brighter, magnitude 6.6 and larger, 12.2 arc minutes in size. And there's a reason for it, because it's 14,300 light years distant. Its right ascension, 16 hours, 57 minutes, 8 seconds. Declination, minus 4 degrees, 5 minutes, 58 seconds. And given its size of 12.2, its actual size is about right here. So we are seeing some of the perimeter stars in this lovely summer globular cluster. And there's a reason why we see lots of globular clusters in the summertime, and that has to do with the fact that many of them are spiraling in towards the core of the Milky Way galaxy, which, as you probably know, lies between Scorpius and Sagittarius, roughly about 15 to 20 degrees south of the celestial equator. So there's our look at Messier in Ophiuchus. Continuing with globular clusters, you'll note that this one is not as compact as earlier clusters. However, it is condensed to the center, so it is obviously not an open cluster. This globular cluster, like the last, is in Ophiuchus, the snake charmer. Magnitude 6.1, 14.5 arc minutes, 16,000 light years distant. It's at right ascension 16, 47, 14. Declination just below the celestial equator, minus 1 degree, 56 minutes and 52 seconds. And there is our view. Here we have probably the most spectacular globular cluster in the northern hemisphere sky. It's in Hercules, magnitude 5.8, large, 23.2 arc minutes and 25,100 light years distant. We are at right ascension 16, 41, 41, declination 36 degrees, 27 minutes and 37 seconds. The globular obviously would spill well outside the field of view, even across the 20 arc minutes that make up the longitudinal section of the TFT display. It's quite compact, has a distinctive shape, which I've always thought of as being kind of like spider-like or beetle-like, Egyptian desert beetle type. So there is our view of our next Messier globular cluster. There is, of course, a second globular cluster in Hercules, fainter, magnitude 6.5, half the size, 11.2 arc minutes, roughly the same distance, 26,700 light years. It's at right ascension 17 hours, 17 minutes, 7 seconds, declination 43 degrees, 8 minutes, and 11 seconds. It is virtually culminating right on the zenith overhead. However, I do not see the roof tri obstructing any aspect of this view. It's quite condensed in its core, and the entire globular should fit somewhere within this realm of the screen. Here we have Messier 14, another globular cluster. This one's in Ophiuchus. Did I just give away the name of this cluster? Do you remember what it was? Magnitude 7.6, 6.7 arc minutes. The furthest cluster yet, 30,300 light years. Right ascension 1737.36. Declination 3 degrees, 14 minutes and 45 seconds below the celestial equator. You get some kind of sense of resolution of stars across the core on this one. Here we see a composite study. It's both a nebula and a cluster in Serpens, magnitude 6.0, larger than the Moon, 30 by 40 arc minutes, 7,000 light years distant, right ascension 18 hours, 18 minutes and 48 seconds, minus 13 degrees, 47 minutes in terms of declination. This particular cluster with an emissive type nebulosity shows nice incursions of dark nebula star-forming regions in the midst of regions of emissive type nebulosity. That emissive type nebulosity, of course, is being ionized and excited by the presence of bright, radiant, probably blue-violet, massive stars. So there is our view of another Messier study. And it also has a common name, which may present itself to your memory based on the fact that we just imaged this a couple of evenings ago. Here we have a second emissive type nebulosity. This is in Sagittarius. It's magnitude 6.0, so it's fairly bright. It seems a lot brighter than 6.0, but that's okay. That's the composite brightness of all the pixels that someone painstakingly determined in the past. It's full moon size, 30 by 30 arc minutes, 5,000 light years distant, with a right ascension of 18 hours, 20 minutes and 48 seconds. It's at declination minus 1611.0. It too, like the last, has a common descriptive name. Here we have a not particularly compact open cluster. It is in Sagittarius. Total magnitude is 6.99 arc minutes, 4,900 light years distant. Right ascension 18/1954. Declination minus 1708. Nice starry field with an obvious but not particularly compact open cluster at center. Returning to globular clusters, another Messier in Ophiuchus. Magnitude 6.8, smallish, 5.3 arc minutes, 28,000 light years distant, about a quarter of the size and roughly the same distance as the most spectacular of the northern hemisphere globular clusters, which we've already shown you. We're right ascension 17 hours, 2 minutes, 37 seconds, declination minus 26, 1605. Nice, richly starred field of view with a very compact core. Once again, I want to remind you the size of this cluster is probably something right about this in terms of its total composition as determined by professional astronomers. Here we have a common named nebula in Sagittarius, magnitude 6.3. 28 arc minutes in size, 5,200 light years distant, with some very distinctive features of excuse me, dark nebulosity bounded by emissive types showing both red and blue spectrum. We're at right ascension 180242, declination minus almost 23, minus 2258, 19. And you can see the nebulosity spilling out in all directions here, which explains why the coordinates are pretty much centered here, even though the bulk of the nebulosity is visible down at about the 5 o'clock position. Here we have a rather expansive open cluster in Sagittarius. Total luminosity of all the stars, magnitude 5.9. 13 arc minutes in size, so it does fit within the field of view. 4,300 light years distant, right ascension 180413, declination minus 2229, 24. Here we probably have the brightest globular cluster visible from northern hemisphere skies, although it lies minus 23 degrees, 54 minutes and 12 seconds in the southern declination, with a right ascension of 1836.24. Globular cluster in Sagittarius, magnitude 5.2, large, 24 arc minutes in size, but a mere 10,400 light years distant. So if it was at the distance of the brightest globular cluster in the northern hemisphere skies, it would be some 10 arc minutes in size, and the magnitude would probably dip to about magnitude 6.9. So it is not comparable intrinsically to the brightest northern hemisphere cluster, but its proximity gives us a very spectacular view. Here we see a screen peppered with brightish stars. Open cluster in Sagittarius, magnitude 5.5, 27 arc minutes in size, 2,200 light years distant. We're at 1757.04 and declination minus 1859.07. Let's have another look, a look at another open cluster, which is even more condensed than the one we're seeing here. This particular study gives a view that is quite globular-esque in nature. However, one thing to point out, most globular clusters are 12 to 13 billion years old. This one's probably not much more than a million or two. So it is, in fact, an open cluster. It's in Scutum, magnitude 5.8, 14 arc minutes in size, 6,000 light years distant. Right ascension 1851.06 and declination 6:16.0 seconds. Here's a cluster, open cluster we had to skip earlier. It's in Scorpio, or Scorpius, magnitude 3.3. So the brightest collection of stars we have seen this evening. 80 arc minutes in size, so it spills well outside the screen. A mere 800 light years distant. Right ascension 1753.51, declination minus 34.47.34, and we're getting a look now and not earlier because it's close to culminating and there's no apple tree branches blocking the view. This next study is a rather anomalous study. It's considered an open cluster, but it really isn't in Sagittarius. It's the brightest region of stars we've seen so far. Magnitude 3.1, very large, 95 by 35 arc minutes, 10,000 light years distant. Right ascension 1817.18, declination minus 1840. But probably the best way to understand this large grouping of stars is that it's really a window that looks deeper into the interior of the Milky Way galaxy than you usually can see. And there be stars aplenty. Here we have another open cluster. It's in Sagittarius, magnitude 4.6 collectively, 29 arc minutes in size, so lunar sized, 2,000 light years distant. We're at 1831.38 right ascension, declination minus 1914.20. And it clearly is, unlike the last study, an open cluster. These stars are gravitationally bound. Most open clusters, as I've pointed out in the past, are earlier this evening, are very young, and they are being picked apart by gravitational tidal forces. Most stars, probably all stars, form in a cluster of one type or another. Our own sun not being an exception in that way, but being so old that it is now loosely associated with far distant stars, and no one claiming through a telescope would claim that our sun is part of an open cluster. This next cluster is actually quite faint for an open cluster. In Scutum, magnitude 8.0, 15 arc minutes in size, 5,000 light years distant, should just squeeze into the screen. Right ascension 1845.12, declination 924.0, and it is a fairly condensed globular cluster with diverse stellar magnitudes, so it's probably a Latin 3 and maybe a numeric 2. I may have those switched around. A little more condensed, a little more disparate in magnitude than the average. Here we have a smallish but relatively condensed globular cluster in Sagittarius, magnitude 6.9. Should just fit in the field, 15 arc minutes in size, 18,300 light years distant. Right ascension 1824.32, declination minus 24.52 and 12. So, what we're going to do now is we're going to knock off from this series of studies because, let's see if, let me just check. That's in Cygnus. Okay. So we're going to call this the early summer series of studies. We began in Serpens, and that was a late fall study. And as I may have mentioned, that was Messier 5. And then we proceeded all the way through Messier 28, skipping around a little bit. I may have missed something. I did a little research online. There was one nebulosity I thought we might have missed that I've captured earlier. But we will be satisfied with this for the time being. And if I do recall the Messier nebulosity I may have missed, then I will mention it in the video tomorrow when I put the screen together. Once again, this is Messier 8, and I'll allow the image to generate, continue to generate as I skip through. Skipping over a couple of globular clusters. I'm now up to Messier 11, open cluster. It's quite nice. 12 is a globular cluster. 13, of course. 14 is a globular cluster. 15, we should be coming up on, and Messier 16, a nebula. Let's take a look at that. I believe that may be the eagle, but there's your view in color of Messier 8. What we have here is Messier 27. It's more of a mid to late summer study. Planetary nebula in Vulpecula, magnitude 7.3, 8 by 5.6 arc minutes, 1,300 light years distant. We're at right ascension 1959.36, declination plus 22.43.16. You get bonus points if you can give the popular name to this cluster, as I say, this planetary nebula, as I say, Carpe Noctem.